Evaluate the limit using L'Hopital's rule. L'Hopital's rule applies whenever you have a limit that results in an indeterminate form, and most commonly 0 over 0 or infinity over infinity. Let's see what happens when we plug in the limit value. So if I plug in the limit value, what's going to happen is the numerator is going to grow without bound, because when you have a polynomial function as x goes to infinity, it goes itself to infinity. The denominator is also growing without bound, because an exponential function, as x gets larger and larger, the value of the exponential also gets larger and larger. So we have this indeterminate form. And L'Hopital's rule can really help out with limits that result in something like this. What it says is to take the derivative of both the numerator and denominator. So this would be 13 times 3 is 39, and then that's x squared, over the derivative of e to the 8x would be itself times the derivative of the exponent, which is just 8. So this would be 8 e to the 8x. Now after you apply L'Hopital's rule, you should just check and see what's happening now. So quadratic function is going to grow without bound if you allow x to get larger and larger. Same thing for an exponential, so we still have another iteration of L'Hopital's to go. So as I do this next iteration, I just do the same process. I take the derivative of the numerator, so 39 times 2, let's see, 40 minus 4, so, 40 times 2 minus 2, so 78 x. And then 8 times 8 would be 64. And I could reduce these coefficients, but I'm not going to, because right now I'm just looking for what happens as things go to infinity. So what would happen is the numerator would still go to infinity, and the denominator would still go to infinity. But if you'll notice, even though we're doing multiple iterations here, the numerator is going to infinity a whole lot slower at each stage, because we went from a cubic to a quadratic to a linear. And on this next iteration of L'Hopital's rule, what will happen is we end up with a constant in the numerator, and then 64 times 8, that's 512, so 512 e to the 8x. Now what happens is this. So as the denominator gets larger and larger, as x gets large, the denominator will get larger and larger, so it still goes to infinity. The numerator is a constant, so we have the denominator of a fraction growing, but the numerator staying the same. What happens in that situation is it pulls the value of the overall fraction down to 0.